you may notice that I skipped the letter D on this problem set. That is one that we did essentially in class. Cosine to the fourth minus sine to the fourth can be factored. See if you can find that in your notes. We've already done that problem. This is one that's new to us, and this one's a little funny because although this is clearly the more complicated side, I don't have a formula for cosine 3x. We don't have a triple angle formula. So I don't really see any way that I would simplify this and somehow end up with what I have over there. So in kind of a reverse of sort of how we normally do this, I'm actually going to start on the left, and I'm going to try to make it look like what I have on the right. So the way that I'm going to start on the left is by recognizing that 3x is 1x plus 2 more x's. This is the same as the cosine of x plus 2x. X plus 2x is the same as the cosine of 3x. All right, well now we have a cosine of a plus b. And if you look in your notes, you have a cosine addition formula. It's one of those formulas you don't need to remember. You can look it up, or I'll give it to you if you need it. So it would be cosine A, cosine B, minus sine A, sine B. So here our A is x and our B is 2x. So it's going to be cosine x times the cosine of 2x minus the sine of x times the sine of 2x. And my job is to somehow take this and turn it into this thing we have over here on the right. And I know that I'm going to somehow want to get rid of this cosine 2x and this sine 2x. So I'm going to start by plugging in for this sine 2x here using the sine double angle formula. I'm going to leave this alone for right now. You'll see why in a second. The double angle formula for sine is 2 sine x times cosine x. So now I have a sine squared there. So I have cosine x times cosine 2x minus 2 sine squared x cosine x. And at this point, I'm like, okay, I have some sines here, and I'm trying to get all down to cosines x and nothing else. So what I'm going to do is I'm going to use the double angle formula for cosine, and I'm going to use the version that only has cosines in it. You have 3 versions of this, and I'm going to choose to use the one that only has cosine squared in it. So if you look that up, I'll let you look that up on your own, but it is 2 cosine squared x minus 1 is the same as the cosine 2x. That's one of our versions of the cosine double angle formula. And now I get to distribute that cosine through. Cosine x times a cosine squared is a cosine cubed. So that's 2 cosine cubed x minus cosine x minus 2 sine squared x cosine x. All right, you're like, let's see. Kind of on the right track. I have some cosines cubes, and I have some cosines, but I don't quite have what I want looking for. And I also have this sine squared. I don't have any sines in where I'm trying to go. So what I'm going to do is I'm going to replace that sine squared with 1 minus cosine squared. Because of the Pythagorean identity, I know that I can replace that with 1 minus cosine squared. So here's what I get. I get 2. I'm right where that sine squared was. I'm going to put 1 minus cosine squared. And I ask you when you do this to rate for this, for this equal sign. The reason I know that this is equal to this is by the Pythagorean identity. Just telling myself why that works. Now I can distribute this negative 2, make sure the negative sign comes and changes that to a positive. So 2 cosine cubed x minus cosine x minus 2, and then plus 2 cosine squared x times cosine x. And then finally, I need to distribute that cosine through as well. I probably should have done a step before. And so now I get 2 cosine cubed x minus cosine x. I have a minus 2 times cosine x minus 2 cosine x. I have a plus 2, and that cosine comes in and gives me a cosine cubed. So what am I left with? I'm left with a 2 cosine cubed here and 2 more cosine cubed there. There's my 4 cosine cubed. I'm left with a minus cosine x and minus 2 more cosine x. That's equal to minus 3 cosine x. So I would just write that as my final step, that I have all of the pieces that I'm looking for. Cosine cubed x minus 3 cosine x. And I'm done. That's what I wanted to do.